Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we will discuss poultry preservation. In previous lecture, we have already discussed refrigeration and freezing technique. In this lecture, we'll continue that topic and learn some new and versatile poultry preservation techniques. So, let's start with introduction. Fresh meat is perishable since it contains all nutrients required by spoilage bacteria. The pH is not inhibitory and it has abundant free water. Storing meat after slaughter represents a challenge to meat processors, retailers and consumers. If proper storage conditions, for example refrigeration or other preservation methods, for example heating and irradiation, are not used, the meat will spoil within a matter of hours or days. In areas where refrigeration is not available, poultry is marketed live and is slaughtered immediately prior to consumption. In areas where refrigeration is available, modern procedures such as use of HACCP systems ensure low microbial counts and consumer safety. The history of food preservation method employed by human is very long. Thousands of years ago, people were already using different methods without necessarily understanding the scientific principles behind them. Some historians recognize two major periods in relation to food consumption. First is regarded as food gathering phase, which covers the time between 10,000 and over 1 million years ago, when humans first appeared on the planet. The second is food producing phase that still continues till today. It appears that food spoilage problems were encountered earlier in second phase, when people started to produce and store their own food for extended periods. Spoilage problem and foodborne diseases caused by improper handling and storage have required some innovative solutions. Drying was one of the earliest methods employed to treat the food like grains and fruits, but was also used to preserve meat. Some cultures discovered that drying and smoking meat over a fire could sustainably extend the shelf life of the product. Later, fermentation of grain was also started. The Samaritans were known to use salted meat, fish, and dried skin. Salted meat was also used by Israelites, the Chinese, and the Greeks, the last name passing the technology on to the Romans. Evidence of production of fermented sausage by ancient Babylonians and Chinese. It goes as far back as to 1500 before the birth of Christ. It is doubtful whether people at the time understood the nature of food preservation by fermenting organisms. However, they used the method fairly successfully. It was probably common to seed a new batch of food with material from a good fermented batch and by the means propagate the right culture to reduce the chances of spoilage. Today this practice is called backsloping in the meat industry. It is also doubtful whether people fully understood the role of food in transmitting diseases or danger of eating meat from infected animals. One of the most important events in the food preservation occurred about 200 years ago, when Francois Appert succeeded in preserving meat in glass jar after keeping them in boiling water for extended periods. His development of canning process in 1795 won a French government prize of about uh, 12,000 francs for establishing a practical method of food preservation. In 1810, Appert obtained a patent for his process and development. This development preceded by Louis Pasteur by about 50 years. Pasteur, who is considered to be father of modern microbiology, demonstrated the role of bacteria in spoilage of French wine and suggested ways of preserving the contamination and spoilage. This process developed by Pasteur is known as pasteurization. Some commonly used preservation techniques in meat industry are heating. Heat is used in the food industry and some professions like medical profession to inactivate the microorganisms. The degree of microbial inactivation depends upon the temperature and exposure time. Generally speaking, two levels of heating processes are used by food industry. The first is pasteurization at a range of about 60 to 90 degrees centigrade for cooking poultry products. Usually, temperature is maintained between 70 to 75 degrees centigrade, designed to inactivate some spoilage organisms and most of the pathogenic bacteria. The shelf life of the product is extended, but it must be refrigerated. The second level is referred as sterilization, where temperature is above 100 degrees centigrade is used to prepare so-called commercially sterile food products that can be stored at room temperature for an extended period of time, like canned food. This process results in killing of all spoilage organisms as well as destroying the food poisoning bacteria and virtually all spores. All heat treatment will result in changes to the product in terms of texture, flavor, odor, and microbial load. The extent of the change increases with the higher temperature and exposure time. The degree of microbial destruction by heat can be described by decimal reduction time for a particular heating temperature, which time is necessary to reduce the viable count to 10 folds. Decimal reduction time, we have already discussed this in our food microbiology course. Overall, there is a quite large variation in the heat sensitivity of different vegetative bacteria, spores, and viruses. Cooking methods can vary from cooking the meat in its own juices to grilling and frying in oil. Heat can be transferred to the product with three different ways: conduction, convection, and radiation. In conduction, the heat is conducted from an outside source and is transferred directly from one particle to the next with little or no mixing or no movement of the product, which is usually true for solids, semi-solids, and viscous foods. Convection. Convection involves heat transfer by mixing and moving the particles in the fluid. Heated particles are less dense and move up to the top, whereas the colder particles are denser and move to the bottom. There is more efficient heating process than this is a more efficient heating process than conduction, since it results in mixing of hot and cold particles via heat currents. Additional mixing during heating can be achieved by agitation, pumping, and stirring. The coldest point in the vessel is above the